Hello everyone. In this session we are going to learn Oracle Memory Management in Oracle Database 19c. The database is basically the combination of two parts, which are database instance and the physical database. When we say the database is started, we mean that memory is allocated and background process are started. The basic memory structures in the Oracle database are System Global Area or SGA and Program Global Area or PGA, which is non-shareable, that is, every Oracle process has its own PGA. Oracle database has many background processes and server process for different purpose, which mange client application requests, user request, and interact with Oracle database and background processes. Now let's how to manage memory structure in the Oracle database. Let's start to see how to monitor SGA first. SGA has many components, like shared pool, flashback buffer, in-memory area, memory optimization pool, database buffer cache, redo log buffer, large pool, shared I/O pool, stream pool, Java pool, and fixed SGA. Alright. The two parameters of SGA are SGA_target and SGA_max_size parameters. Automatic Shared Memory Management, ASMM, is enabled when we set value SGA_target is a value different from 0. SGA_max_size specifies the maximum size of the SGA for the lifetime of the instance. SGA_target can be dynamically sized while the database is up and running, up to the setting of the SGA_max_size parameter. This defaults to be equal to the SGA_target, so if you plan on increasing the SGA_target, you must have set the SGA_max_size larger before starting the database instance. As a DBA, determining the size of Oracle database instance is very important for performance reasons. You must allocate adequate RAM for instance to run smoothly with, of course, acceptable performance of the databases and applications on top of it. But by just allocating more RAM can sometimes result in resource wastage and lead to paging and swapping problems. Now let's check the total memory allocated. SGA_target parameter is dynamic and can be changed during normal database operation, whereas SGA_max_size is a static parameter. So take effect on the maximum size allocated, we need to restart the database. PGA monitoring. The second basic memory is PGA. The Program Global Area, PGA, is a non-shared memory region that contains data and control information exclusively for use by those server processes and background processes. Oracle Database creates server processes to handle connections to the database on behalf of client programs. In a dedicated server environment, one PGA gets created for each server and background process that is started. Each PGA consists of stack space, hash area, bitmap merge area, and a user global area, UGA. A PGA is deallocated when the associated server or background process using it is terminated. There are two parameters in PGA. The first one is PGA aggregate target, and the second is PGA aggregate limit. Now let's take a few minutes to see them in detail. PGA aggregate target. The parameter specifies the target aggregate PGA memory available to all server processes attached to the instance. You must set this parameter to enable the automatic seizing of PGA memory components. This parameter is optional for pluggable databases, PDBs. PGA aggregate limit is a dynamic parameter that needs a database restart to take effect and specifies a limit on the aggregate PGA memory consumed by the instance. Before we resize PGA, we have to check the processes that are using PGA. Good. Let's provide a value different from 0 for dynamic allocation of its components based on workload. To do so, first let's check the memory size allocated for PGA and then reallocate it. And finally check the change in the memory size. Dynamic allocation of SGA in PGA. We have two basic memory parameters for automatic memory management: memory_target and memory_max_target. Let's see them in detail. Memory_target. Memory target is the parameter that Oracle uses to tune SGA and PGA components automatically. Memory target specifies the total memory size of SGA and PGA. The memory target should be set to a relatively high value to achieve better performance. When using automatic memory management, the SGA_target and PGA_aggregate_target act as minimum size settings for their respective memory areas and will increase when the workload increases. Memory_max_target. Memory max target is the parameter, which is the max limit for the memory_target that can be tuned dynamically. Let's check the current value of the parameters, reallocate, and then see the change after restarting the database.